Hi, everybody. I hope you had a good break. We are going to get stuck in to our first user presentation, collaborative well planning in Aker BP, interoperability between SLB and Halliburton. So I'm very happy to hand over to Max. Thank you. Thank you.
Not sure if this, yeah, it's working. So, welcome everybody today. My name is Max de Groot, working in Aker BP as the OSDU delivery lead, and on stage we got Kai, Kadri, and Dave as well, and to help me or support me a bit on the presentation today, going through a demo and some closing words as well. So, welcome everybody. Yes, so today we'll be talking about our collaborative well planning, or CWP in Aker BP. And I'll start a bit with an introduction on Aker BP. So in Aker BP, we really focus heavily on new technology or digital technology, which will help us bring down our emissions, which will help us improve our efficiency, and which you also can see in our cost per barrel, right? So we also believe strongly that you should always test thoroughly but very quickly these new initiatives or new innovations so that you either succeed quickly, or you fail quickly, improve yourselves, or be a bit more pragmatic and then succeed afterwards. And then also OSDU being at the core of that, or the foundation, like helping us to get new innovations in, create new workflows, improve workflows. That is kind of our goal, which then also closely aligns to our priorities in the company, which are good data quality, good data governance, which is the foundation of everything for us. It's also new innovations or new workflows that need to go across BU or cross discipline so that you create the most valuable, or you widen the value as much as you can, so just not siloed or per discipline. We also believe that you should, when you do these type of innovations, you do that with your partners. Or with vendors, and in the form of partners and alliances, just like we do now with CWP, with Microsoft, SLB, and Halliburton. And then I think I forgot one, which is one of the new main priorities in the company, which is scale AI. And we still believe that AI needs a good, solid foundation of data to be able to give proper output, right? So that's a bit of an introduction into who we are, what we do, what we value, and how we then got to CWP. So this may be a difficult picture to read, but I'll just take you through it. So this is kind of the time it took for us to do well planning. On the purple line, you see let's say the data flow as being worked by one discipline, going to the next, going to the next. You hit the ceiling, you have to go back to some reiterations or some improvements. And that process was very lengthily siloed. Data wasn't really flowing in a standardized way. The knowledge built up in green is flaky and not really steep as you want to see it. Plus the mental health for the well planner was under stress because everybody was attacking him from all sides at the same time. So we wanted to improve this massively. And then we came up with collaborative well planning. So this is what we have nowadays, where kind of on the right side, the need for a well is born. Then in Petrel, we have the initial data types. They get tagged by a tool that we have, which is the RockUC governance tool. Data gets tagged, gets put into Studio, and then from there, Cognite grabs it, pushes it into the Halliburton environment, data gets reworked, and then the well plan comes out, and then that's kind of a loop around. But it's still point to point. There's still some loss of information. There is loss of lineage. I mean, it is massively improvement compared to what we had before, but it's not enough. We always achieve better, smarter, faster workflows. So that's why we want to go to this. OSDU in the middle, and then on both sides, the vendors that we work together with to do this collaborative well planning. And then on the right top side is what we presented also in Amsterdam in May. That we all follow the right well-known schemas, and we also aligned on the DDMSs to use. So yeah, and then using OSDU in the middle is lineage. You all reach out to the same data source. You all write to the same data source. The whole, standard OSDU story. But this is how we envision it to be improved. So the how, and that is collaboration. And it's just not normal collaboration, it's very tight, open and transparent collaboration. You want to breathe in each other's necks, more or less. And I'll promise you, we'll improve this picture as well for the next forum. I'll keep it a surprise, but it will be a better one. Strong executor support. So you always need to have the top dogs helping you to support you, right? If it's not a priority for the company, it will trickle down, and then at some point you lose track. And so priority from the top, that is what is needed. Then reasonable aligned roadmaps. I mean, we all have our way to go and to do things and different speeds and different priorities. So what we need to make sure is that we start at A at the same time and we finish at B or C at the same time. That not one company is waiting for the other, loses interest, have to reshuffle their sources or resources. So make sure that you have reasonable aligned roadmaps. Now here's my Dutch proudness coming in a bit. So what we want to make sure is that we ensure sustainable and proper commercial end solutions. Now, this machine is the most complex machine ever built by men, which is in the Netherlands, and it's making computer chips, super cool. Not saying that we want to make something super complex, but what I'm trying to say is that we want to make workflows that have amazing output, right? The best possible output that we have. I do not hope that this is how collaborative well planning is going to look like, because it looks very complex, but it's really cool. That's the point. So then another how is on a technical level. You need internal and external OSDU expertise to align on definition data TDM as usage. Right? You need to have the brains, because it can be quite difficult. So, and this is also for me now a time to not only thank SLB, Halliburton, and Microsoft, but also people outside of this little group that helped us a lot. So, for example, Farouk, I'm not sure where he's sitting, but Farouk there. Pierrick also helped us a lot, and Laurent Denis. They were really valuable to our project so far. So big thanks for that, guys. Then the real technical part, or let's say the OSDU technical part, is then using persistent collections to support, let's say, our shipment of data types from one location to another, or from one application to another. So we package the data just like we've seen in the original collaborative well planning workflow. We package the data, and then it gets sent to the applications. And that works quite well, actually. So now I'm going to hand over to initially Kai. He's going to take us a bit through the SLB part of the demo. So how do we do the CWP workflow? Then Dave afterwards will take us through the Halliburton part, and then what gets created there. And then it comes back to Kai again for the consuming of that new data type.
All right.
Yeah, you can. Yeah.
Thanks very much, Max. So thanks for the introduction. Those of you who don't know me, my name is Kai Morfeld. I'm working with SLB, geophysicist by background with about 25 years experience. OSDU grew to my heart a couple of years ago, and since then I'll try to give everybody of our customers advice to this, or anybody who actually wants it. So come up to me and I'll help you on OSDU. We'll put together a couple of videos now, Dave and me, to show you how the workflow that Max just described is actually going to look like in the applications, so to the end users, so to make it a little bit more tangible, just not just PowerPoints. So we're going to go through this, and I show you the first part where we're starting the deliberation from Pichel. Right. Okay, so the first thing, when the video starts, okay, the first thing we need to do is to set things up. In order to do this, we're creating a data space that we want to collaborate on. That data space is represented by an OSDU data group, so we can actually attach legal tags to it, we can manage the users, we can manage the entitlements of those users that are collaborating in that space. So once we have that data space set up, we're going to save the Pichel project to OSDU. So that is simply done by using the Project Explorer. In Pichel, you're giving it a description, and you select the data space that we've created before, so you get the same context, and save it into OSDU. So once we have the Pichel project into OSDU, we can get to the meat of it, which is liberating the horizon. So the horizon in question here right now is the one that is kind of highlighted in this view. There's a bunch of other interpretation data that might or might not be relevant, but for this purpose, we want the horizon. So I turn off a bunch of the other data that is already visible there, And the rest, or what you see in the end, is the horizon that we want to liberate, plus the geological targets or the drilling targets that have already been shared with Halliburton to plan the wells. So there's a bunch of drilling targets here, and we need the horizon now shoveled over through OSDU in order to guide those well planning workflows. We do this simply by using the Petrel data liberation. We pick the data type that we want to liberate, which is a seismic horizon, and we pick the seismic horizon that we want to liberate, which is the AAA2A. Pick it, and just simply click Save and liberate it to OSDU. Now, to prove actually that we have that data in OSDU, we can go back to the data space we created before, because all the data is pushed into that data space now. And we just open it, and we see the Petrel project being in OSDU now. We obviously liberate some metadata with it, which we can look up. So we have some information about that Petrel project, for example, what kind of version it was, but also the name or other data that is relevant for the context of that collaboration workflow. We also see the seismic horizon in OSDU now, which is the one that we liberated. We have the same functionality. We can look at the actual OSDU record, which is the seismic 3D interpretation set, and look at the name, and we see that that horizon is now in OSDU. Now, we have now the right data in OSDU, so the next step is really to do the well planning, and I hand it over to Dave.
Thank you, Kai. So those of customers who have our borehole and seismic data management solutions allow us to QC and ingest data into the platform. We'll recognize this screen. I don't think it's playing yet. So we have data management solutions around master data in OSDU. Here we're seeing an enterprise search application that becomes part of that toolkit. And this allows people to discover data in both OSDU and non-OSDU data sources. So here I've put in a very exact search with the data that Kai had transferred. So we're seeing data live being shown from OSDU. And this tool allows us to select that data, put it into a shopping cart, and deliver it to any of our connected data sources. So that's going to transfer into OpenWorks. So the first application we're going to show is OpenWorks. So we transfer that data. I'm showing a single object here. The key thing is, for this demonstration, we really wanted to focus on horizons, because for both of our companies, this is the first reservoir DDMS object that we've focused on. So it's really key that we do this so we can add the other data types. Once we're in decision space, we can consume all of the objects. Here, I was showing in a data management application, but we're working to integrate with those persisted collections. And in the next iteration, we're actually going to automate the ingestion of all of those data objects in one using the persistent collection purpose ID. So Kai will make it with a flag of collaborative well planning. We'll automate the ingestion into OpenWorks. We generate our well plans. We have the ability to publish those to OSDU. That's part of our Agile Asset Management Suite, where we can actually look at the various well options, and so that we can come back to those later. But I'm going to push that one well you saw in the last screen through to EDM. So we're integrating not just OpenWorks, but EDM. This is our digital well program, and we're going through doing the final well engineering and trajectory design. And when we complete that workflow, you see we've got a new publish option to OSDU, and we get a notification event come up to show when that's complete. So we're starting to integrate not just OpenWorks with OSDU, but EDM with OSDU. We've completed it for a number of data types now, and through each of these workbenches in the drilling suite, you'll be able to publish all of those data elements. So we're working on casing design that will be coming out this month as well. I'm going to pass it over to Kai because I've published that trajectory back. We want to take that back to the subsurface world to QC it and see whether we need to do any iterations for the final design.
Thanks. All right, so now we have the planned trajectories in OSDU, and we want to bring them back to Petrel, and we want to show you that they actually match up with the drilling targets that we saw in Petrel earlier. And we simply do this by then starting Petrel up again and pull that as a data package into Petrel, which Dave alluded to. We're using the persisted collection. So I'm again in my Petrel project, and I connect to OSDU through the data platform, and I'll search for the data package that we created, which is actually a persisted collection. I'll pick that data package, and tell it to load it into my Petrel project. So that's a relatively simple operation. And we're pulling this into the Petrel project, and you see on the input tree on the left side now, there's a number of trajectories now coming in. Yeah, you just saw that. So I'm going to now enable or show some of these trajectories, and we can see that those are the trajectories that Dave earlier showed in their application, and they now match up with the drilling targets that we had before. So by this now, we're basically, as Dave said, this is the first time we used the RDMS actually to do an interoperability workflow. The stuff we did before with the wells and the points and everything was a bit simpler, but this is really a big step forward, and we're looking forward then to use more interpretation data like surfaces, faults, whatever is needed on for the collaborative well planning workflow to complete. And we can iterate this over and over again. There's no problem sharing this to OSDU. So that's it for the demo.
Nice.
Max?
Yeah, thank you. So I guess yesterday, I think it was mentioned that people want to see a bit more cross-vendor collaboration. I think this is a really nice example of that. And I think it's also really cool. And I can only say that the collaboration has been, I mean, it takes a bit of alignment at the beginning, right? But the moment you define your goal and you define the roadmap that you want to follow, that collaboration has been perfect. So thanks for that, guys. I guess this picture just shows on paper, like in a simple diagram, what we've just seen in the demo. Don't think I need to go through this, but when you look at the slides later on, just have a quick look at this little mini architecture and the steps to follow. Then I guess we started presenting this bit in Amsterdam in May, right? And we want to show you the progress that we've made so far and what we then plan to do next. I guess last time we were working on wellbore, trajectories, and drilling targets. And now we have added 4 more data types, and the plan is to putting a bit of pressure now on ourselves, but for the next forum to add the rest of the data types as well, or as much as possible, of course. So we are progressing, and also by doing these data types, we also realized that actually we can start using those data types also for different workflows. So it's just going to become bigger and bigger and better. Then we also have lessons learned and next steps, and we tried to combine the good with maybe some opportunities. So using the OSDU persistent collection to facilitate data transferring of data types / products. So I guess this is, if you want to share your data between partners or between applications or between vendors, that's the persistent collection or data package, I like to call it a package because you kind of put it all together, right? Is very valuable. Of course, you can always write to the same location and read from there, but getting it into a package, kind of isolating it what you need is working quite well. So I think that's a big opportunity for other workflows in the future for us. Then the first interoperability project in Aker BP shows us that OSDU solves these connection hurdles, right? Where you normally would need multiple plugins, maybe other vendors coming in to help you out connecting different tools. This is going to solve a lot for us. And also then solving this multi-vendor is just going to create speed and value in a much better way than it did before. So I would only argue that, as operators, we should do a lot more cross-collaboration between different vendors or between your different vendors. And then maybe kind of a sidestep, I also think that maybe for the smaller vendors, which is, for them it's maybe a bit more difficult to get into OSDU, open up your dev environment, for example, to help them develop their tools on top of OSDU. Then involving the OSDU interoperability team, so that has been super valuable. This was for us the first time. I'm not sure if other operators do it already quite a bit, but I think, is it still there? Yeah, it's still there. But I think using whatever the forum has to offer is only going to be valuable for your task or workflows or your innovations or your improvements. Then also picking a workflow rather than just doing it data type per data type, it's just straight away going to bring you value. Plus, it is also going to motivate the business because they straight away see, okay, we've been talking about OSDU forever, but now I can see it in action, actually. So that is, I think, for us, one of the bigger lessons learned. And now I would like to hand over to Kadri for a few more words, because I think, oh no, sorry. room for improvement. We also think there is some room for improvement. So the ambiguity in the JSON data model. So some of the words in the JSON might be similar, but they mean different things. So maybe with some more examples, help people understand what is actually written in the JSON file. We also see some opportunities for improvement on the RDDMS. And then for us for us specifically, we have a kind of a way to deal with system of record and system of engagement, where we do want to do ACL swapping, where we already see an issue with the RDDMS. You know, the data spaces have their own ACLs, and yeah, we kind of want to see if we can improve some things there to make our lives a bit easier. Sorry, now, Kadri, thanks.
If I can open this up. Thanks. So I want to keep it short, like a couple of things. So one is OKRs, again, coming back to that, like the first room for improvement, which is the semantic equivalence and use cases, sample data, test data. That's already OKR Q1. And Jacob from Exxon is our sponsor. Thanks, Jacob, for volunteering for that. So I just want to talk to that. The other thing is interoperability. It's becoming super important. And I think technical interoperability is one thing, so you might take it for granted. But when we show the demo, it might seem simple, but actually what we're showing is two stacks from two biggest ISVs kind of like interoperating with OSTU out of the box. So it just connects, well, kind of out of the box, but it connects to OSTU, and then that's value right out of it. But again, technical interoperability is simple. I think the second level of interoperability is human-to-human interoperability, so these events help a lot. So yesterday, there was a party outside, and we were sitting in a room around the corner together with SLB, Halliburton, and thanks to Laurent and then the whole AspenTech team, and with AspenTech, 3-man ISVs sitting in a room, skipping the great food and booze, and then talking about how we fix things with RDDMS. So I think that's the human interoperability thing is the most important thing in that sense. And then having my OSTU hat on, it wouldn't be possible without OSTU. I mean, if you remember last year when we were here, we had representatives from SLB and Halliburton on the same stage, and that was like, wow. And then now you see it in action. We're actually developing a product together, like the two of us, and a big welcome to AspenTech help with the reservoir DDMS. So that wouldn't be possible with OSTU. Thanks for all of your work. Thanks for OSTU. I think that human collaboration, having open discussions, open conversations is amazing. Thanks for that again.
So that was our CWP presentation for today. I hope to maybe show a follow-up on the next one in the new year. So I guess that's the thank you and Q&A maybe.
Hi, DJ from GS Software. Great presentation. It's really good to see how OSDU can help collaboration between two suites of applications. One question I have is, could you talk a little bit about what kind of issues you ran into or any learnings in terms of maintaining hierarchy of data, lineage, metadata, as you transfer data between SLB and Halliburton suites of applications?
I guess because we follow the well-known schema, right? So there's that whatever is in the schema is being captured by both sides. For the collaborative well planning, we do, so what we have currently is adding, let's say, a tag to the data, which is then picked up by Cognoid, and then it flows over, and that tag is more or less lost currently. I mean, there's some manual process to capture it again, and this is something that we want to add to, but probably Dave wants to mention something later on, but we want to add this into this process as well. So it's going to be refined a lot more and detailed out a lot more. But
yeah, I mean, I think there's more work to do, particularly on the lineage. The first thing you find out is your your data models require a different minimum set of attribute and values. So we have discovered that. We've used extended attributes in the short term, and we've communicated those between us. So we both pick those up. What we found very efficient is that we fed those back into the community. So again, going back to Laurent, he talks to the data definition teams, extend the data models to include that minimum set of attributes. So it's a work in progress, but we find it quite efficient, getting through some of those challenges.
One more comment to this one. I agree with that, but I think the key or the solution to your question is really Max, right? So obviously, like Dave said, there are different data models that need to come together somehow in OSDU, and that is work. But it's the operators that need to enable that. And they can, as you see, right? So just keep it going.
And then I want to add one thing to that. It's just like OSDU is all about well-known schemas, which is for the metadata. And there's also the bulk data. Like if you're sending trajectory back and forth, then you need to have some, we call them conventions, to have the same sort of understanding from that data, or you can call it semantic meaning. The other thing is like the well-known schemas, some fields are super complex. It can mean a lot of things. So while you're syntactically correct, you won't be semantically equivalent between the two entities. So you need to make sure that, again, you have the conventions agreed upon between different groups exchanging data on the meaning of the data that's in those fields. So those are things, probably it will be part of the sample workflow or sample data flow thing. That's the only way to do that. And then the other thing is like, you need to make sure that you have, even if it's OSDU on both sides, you have the same reference values to get back and forth. So there's a couple of things you need to look into based on the semantics of the workflow, and then make sure that they mean the same thing on both sides.
If you want to start.
That might be a bit more work.
Yes.
So I think we showed the sort of handovers there, and it probably did look a bit clunky. I mean, I showed a data management interface because the focus is on building that layer that allows us to exchange data and having a set of rules and conventions around it. In such a way that there's an API, so I don't expect, so from a data management perspective, I might use that interface if I want to start a new project and I see OSDU as a feedstock for that new project, right? So it might be a data manager creating a collection of data, put it into a project for subsurface interpretation. How we see it working in a workflow like this, we really want that seamless availability of the same data objects. So Aker BP are not going to use that data management interface to move the data. Kai is going to write it with a persisted collection. We're working on a convention and a set of reference values that define the workflows. So I get a notification that a collection of data has come across from a gate process that I want to consume, and I will automate the movement of it into the application. So the user doesn't see any of that, right? So we're not rebuilding the apps on OSDU, but as much as possible, we want it to be completely transparent through that process.
Yeah, so I can agree to what Dave just said. I mean, what you describe is what everybody wants, right? what we're working right now is a couple of levels down, and maybe some of that is still exposed in the workflows. But over time, I think the user interfaces will kind of hide that, and it will look pretty much like you described it. And because in the end, we want this to be as simple as possible for the users, while we're still maintaining a high level of flexibility underneath to deal with the fact that there are different data models, and there are legacy applications out there that are 20 years plus in the market, right? This is something, millions lines of code you're not changing overnight, so you're gonna have to deal with it somehow. But the fact then that we can use OSDU and forces us onto this common data model helps us a lot.
The three different versions of the data, sorry?
I can take it
Yeah.
from
One in open world, you've got one data store and control, you've got one in OSDU. How do you manage the coherency of those different versions? And as you scale out to additional applications and data stores, how do you keep all these things in sync?
So the way we're treating that is, so in this workflow at Aker BP, it's not that we're interpreting a horizon and Kai is interpreting a horizon and we're managing version controls with different versions of that data object. When Kai is handing over that set of data, that is a data product that comes from Subsurface. Subsurface own that, and they own it in Petrel Studio. When it goes to OSDU, it is a system of record object that they want recorded at a decision point. We pick it up and use it, but we're not altering it, right, in this workflow, right? So we're picking that up and we're using it as an input to generate a new set of objects. And then again, we publish those objects as a system of record. So I think when we talk interoperability, I think we do need to get more specific with the language of what we mean by interoperability, because it's quite a coarse interoperability and a handover of data products between business processes, right? As opposed to that sort of frequent iteration. And we don't see it as a replacement for OpenWorks. We don't see it as a replacement for EDM, right? I mean, that's Halliburton's approach to OSDU.
I guess also in Aker BP, so we do, I mean, it depends a bit per company as well, like how much of your iteration you want to actually save in the end. If, let's say, an horizon is being picked up by Petrel, you change it in Petrel, it's being pushed back, that's all you want to capture. I don't need to have every click that an interpreter does. I don't need to be capturing that in a new version, whatever what. But let's say if we now want to share data between different applications, in Aker BP we have a kind of a defined governance setup where we have system of record data groups or data space, because we use data workspace as our data management tool. And we have a system of engagement data group or data space. The moment you need to go cross-vendor or cross-application, that is where you save your data constantly to. So if I now did something in Petrel, it needs to go to another application, I might save it then in my system of engagement data group, and then that's being picked up by the other application. Whatever happens in there internally, fine, don't need to see every point like what I said, but then we push it back again. So that's how we try to keep that lineage then alive, or let's say the versioning alive.
So I think there's a goal from OSDU to reduce data duplication, right? By enabling these interoperability workflows where you can share data through OSDU, fundamentally you might think you can reduce the amount of data you have to duplicate to serve every consumer. And I think we're on the way to it. However, your question imposes quite a few things to think about, and Max and Dave already talked about this. So there's the aspect of having some operational data somewhere. And how much lineage do you need for that operational data? How much do you want to keep that? And these kind of questions need to be answered then. There's always some sort of duplication for operational aspects. But when we're considering OSDU as an SOR, then there should be only one version of that data and only one copy of it. There's no need for two or three or whatever, right? Like you have right now in different SOR systems that you maintain today. So I think we're going into this direction. It's not solved, and we're not be able to save any data duplication in the near term, but we're reducing it. So I think there's OSDU offers us to give us some capabilities to pick the lineage and the ancestry to a degree that we know what happened to the data over time without necessarily keeping full copies of that data.